This is modeling expansion of the universe. And we're going to do that with a balloon this time. This is one of the pretty good analogies. Another one they have on here is a rubber band. This is on page 466. I like the balloon better. The best one is the raisin bread dough they talk about here. That's even better, but that's harder to show you. So I'm going to modify this a little bit. What I'm going to do is I'm going to use, instead of just, well, they have A, B, C. So A is the point where you are. I'm going to have that the same. And then there's B and C. I've got B and C, but I'm adding a D as well. So instead of just measuring to 2 other positions, I'm going to measure to 3. So I'm going to measure the positions between A and B, between A and C, and between A and D. I'll measure them with a string, and then I'll record it right here. We're going to talk about time intervals. Let's just say we're starting at time interval 0, and then you'll have to keep count on which one I'm on. I'm not going to do that for you. I'm also not going to make your data table. I'm just going to write the number here for a moment, then I'm going to erase it for the next interval. So you'll have to make a little data table with these. I would say B, C, and D, and the distance they are. Obviously the distances we're going to be measuring in centimeters, but these are going to be stand-ins for light years and hundreds of light years, even millions of light years, like in our universe. Okay? So we're going to start out with the uninflated balloon. I've tried to put the dots in different distances from each other. The red dot is almost on the opposite side of the balloon, not quite. So I'm going to measure the distance from the black dot. Let's say that's here. That's the Milky Way galaxy. And these would represent other distant galaxies, let's say, in the universe. So I'm going to measure between the black dot and the blue dot this way with the string. I'm trying not to have a wrinkle in between. It's really hard to do this with the uninflated balloon. I'm going to put that on the black dot. I'm going to put that right there. And if I pinch it very, very carefully right there, then I know that measuring to there will give me the distance. And what I get is 2.7 centimeters. So for the blue one, 2.7 centimeters is my unit. Okay. And then to the green dot, I'm going to measure from the black dot, which is this one, to the green dot. I'm going to turn it this way. I'm trying not to get a wrinkle in between. Try not to get a wrinkle in between them, as close as I can get it. Again, this is probably the hardest one to measure while it's uninflated. Okay, right to there. And the distance I have is a little bit greater. It's 4.9 centimeters. 4.9 centimeters. And then the last one's probably going to be the hardest one to measure because I practically almost, not exactly, but almost on opposite sides of the balloon. So from the black dot, as best I can do, without a wrinkle, to the red dot, I gotta pinch it right there. And we've got quite a bit more. Okay, 7.4 centimeters. So this is where we are starting. This is where we're starting without inflating the balloon. These are the ones that are going to wind up going right here. So what I would do is put your time intervals along the bottom here, however many we wind up having. Just sort of spread them out evenly. Start with time intervals 0, then 1, 2, 3, 4. You might have to spread them out, use up the space. And then up here you're going to put, well, whatever these numbers get up to, whatever your biggest number is, you're going to want to set it near the top of your graph, and then 0 at the bottom. So just make sure to graph evenly. So let's say this winds up being, I don't know, 40 centimeters, I'm just saying. Then right in the middle that should be 20, and then split that in half, that would be 10. And then each one of these dark lines would be like 5 centimeters. So I'm just saying that might be what we wind up with. We'll just have to see what these get up to. So that is interval 0, that's starting out interval 0. Now I'm going to inflate. It's pretty hard to inflate consistently, but I'm going to try to inflate it with a couple of big puffs, and then I'm going to use this little binder clip to try to prevent the loss of air. Measure quickly. I'm going to replace these with the new ones. So hopefully you wrote these down. Now I'm going to erase them, and this will be our next time interval. The next one, of course, will be time interval 1, and you have to keep track of that. Okay, so I'm inflating. 1, 2 breaths. I'm going to try to do it about like that. Let's see how many we can get in there. I'm going to try to do at least 5 inflations. Now the actual dots have grown, but we're going to measure from the center of each one. This makes it much easier to measure now that it's on an inflated balloon. So I'm going to measure from the center of the black dot to the center of the blue dot, and what I get is right on 7 centimeters. So I'm going to put 7.0 because we can measure to the 10th of a centimeter, so I'm going to do that. Then for the green one, I got to get from the center of the black to the center of the green, pinch it off, and what we get is, line it up right on here. Oh, good, it's 12, it's right on the 12. Interesting, these are coming out right on the whole centimeters for some reason. 12.0 centimeters. And now, to get from the black to the red, I have to look at which direction to go because they're almost on opposite sides, but I want to go the shortest distance between them. Okay, like let's say you were looking for one, looking at the other. Okay, you could measure it right there. Okay, and I could have also gone around the other way, but that would have been longer. Right to the middle. And this winds up being, this one's not on a whole centimeter. This one gives me 17.8. 17.8 centimeters. Make sure to write these down. Now I'm going to do my next inflation, the next interval, and you have to keep track of the intervals. You want to have a little data table so you can plot them on here. And I recommend doing that instead of plotting them directly, although it might work out for you. Then once you've got them plotted, I would connect the blue ones together, the green ones together, or if you don't have any colors, label them as B, C, and D. But we're going to have 3 curves. The way the instructions are written, they only intended you to have 2, but we're going to have 3 of those. Okay, so here's the next inflation, the next interval. Okay, and let's pinch it off before it deflates. Don't want to let too much air out. There might be slight leakage going on here, but it's slower than the process of measuring. There's not much that's going to happen before I've measured them. Okay, by the way, so I'm erasing the last ones again. For these ones, we've got from the black to the blue, from here, the middle of the black to the middle of the blue. And if I put it on here, I now have 10.5 centimeters. And if I measure the green from the black to the green, where is the green one? Okay, oh, there it is. It's gotten pretty far away now. It's way over this way. So I got to put that right on the middle of the black. And I'm going to go the shortest distance to the green. This is the green one. It's getting fainter, but I can still see it. Okay. And then the green one is now, oh, it's 22. It's right on 22. It's funny how many times it just happens to come out right on a whole centimeter, 22.0. And then, let's see, the shortest distance from the black dot to the red dot, I believe would be this way. So let's get the string, we don't want it to fray. Right on the black dot and heading toward the red dot, pretty straight as you can get. Now obviously travel in the universe is like this too, the middle of the red. You think you're going straight, but the universe space is warped, so actually you might not wind up going as straight as you think. Okay, so we are at 33.4. 33.4. Okay, so that is the end of that interval. Write these down. I think I'm going to erase them before I inflate. I think that's a little easier. So you should have these. Here comes the next interval. I'm going to do many of these. You keep count of them. I'm going to do as many as I can with this kind of balloon without having too much risk of it exploding. Of course, if it explodes, I do have the goggles on, which is the recommended safety procedure here. Okay, ready? Here we go again. There we go. Let's get a little harder to inflate it. Okay, so now we're going to measure from the black to the blue, this way, from the black to the blue to here. And what I get is, oh, I let it slip. We're going to measure from the black to the blue again, from the black to the blue to the middle. I want to let it slip this time. And I get 14.2. 14.2 centimeters. Then I want to measure from the black to the green, which is this way. The green is right there. So, to there, from the black to the green dot gives me, I get 17.9 centimeters. 17.9 centimeters. And then you know what I might want to do is that green is fading. I want to just maybe darken it a little. Okay, a little bit darker because it's getting harder to see that one. And then from the black to the red dot, which is right, okay, the quickest way appears to be just past the green line, just over the green line, and to there. That looks like the shortest distance from the middle of the black to the middle of the red. Okay. So I'm holding it tight, don't want to let go. And I see that it is 42.8. 42.8. 42.8 centimeters for that interval. And we'll see how many more intervals we can get. You should write these down. And so we're getting over 40. Remember when I said put 40 at the top? Well, you can't. You might have to go a little higher. You've got to fit all these numbers onto your graph. I'm going to do an even scale. Okay, so the next interval, here we go. Okay, so let's get this fast. Well, let's get a measurement. I think the arrow might be coming out very slowly through the binder clip. So from the black to the blue, what I have is from the middle of the black to the middle of the blue, what I have is 15.3 centimeters. Okay, and from the black to the middle of the green, the black to the green, what I have is, okay, I have 32.3 centimeters. And then from the black to the red, which is now really, really far away, okay, really, really, this way. There we go, all the way from there to there. It's almost on the opposite side. We get, now we are at 48.0 centimeters. Okay, so you should write all these down. Obviously the universe has expanded a lot, Now in the case of this balloon, there's a few problems with this analogy because the actual size of the dots is growing. I know they're harder to see now because they're spread out, but in the universe, the galaxies themselves don't really grow, they just get farther away from each other. Okay, so let me erase these, make sure to write these down, and here comes the next interval. I'm going to do at least one more. Here we go. Okay. I think it might work better if I get this out to it. That seems to hold it. Okay, so getting bigger now. So from the black dot to the blue dot, from here, getting to the point where it's possible it could pop now, back to the blue dot to there, is now going to be 17.3 centimeters. And then from the black to the green dot, those are really getting far apart now. Wow. Okay, from right there to, let me aim this a little lower, there to right there, yeah, is now getting to 34.6 centimeters. And then to get all the way to the red one, let's see again, still farther that way, yeah, I think. But you know what? Now it's, well, I think we'll just keep measuring in the direction we're measuring. It's possible now that because of the stretching of the balloon, it might be almost the same distance to go the other way. Let's see. Okay, so what I get is, there, the red dot, I get, oh boy, I'm getting all the way up to 52.5. 52.5 centimeters in that same direction. Now I'm wondering if I take that length, and if I try to go the other way, if I try to go the other way to the red dot, is it actually getting closer now? I think it actually has now changed, but I'm going to continue to measure it in the direction I've been measuring it. Just keep in mind that's one of the funny things about warp space. I'm trying to think of an analogy where that could actually happen in the universe, but anyway, it isn't always just a straight line to get to something. So we'll see. It's possible the balloon could pop this time. That might be our last set of data. Write that down. I'm going to try for another one, and if it pops, well, we'll just settle with what we have. If we can get one more, I will. Okay, so we'll try to make this one work. Here we go. All right, so this will be the last one I'm going to try. This will be our last data point. Oh, good, the air is not leaking. Good. I think I just had it clamped wrong that one time. It was leaking slowly. All right, so now let's get the measurements from the black dot to the blue dot, from here, the middle of the black dot, to the middle of the blue dot is, oh, now there's a slow leak. Okay. Let's get it quick before it leaks much. That gives us 17.9. 17.9 for the blue one. 17.9 centimeters. Okay, and now from the black dot to the green dot, from the black dot to the green dot. Okay. We now have 36.4 centimeters. And then the last one, from the black dot to the red dot, I'm going to still go in the same direction I've been measuring, just to keep it consistent. Let's say you look this way and you see that galaxy. It's going to be harder to get this great distance here. Yeah, this is right. Okay, that's a pretty good distance from the black dot to the red dot. And this will be our last point. Going from there. Okay, we've got 55.8. 55.8 centimeters. So if you think about it, these two were always the closest, even at the end. So the rate that they expanded will be different than the rates that these expanded. These are the middle ones, and the far apart ones. Why? Because there's more balloon in between them. There's way more balloon between the black dot and the red dot than there is between the black dot and the green dot, as you can see. So there's more room to expand. So there was a lot more expansion when there was a greater distance. And that's kind of like the universe. The way this analogy doesn't work, so think about it, is there can't really be galaxies inside this balloon. It's all on the surface. Okay? So, and also, you know, what's beyond the surface? What does the surface itself represent? There's a few issues that don't quite hold up. But it's a pretty good analogy. And you want to graph them here. 3 lines. Either do them in color or label them B, C, D. Because A is our position. Okay? And you want to put your time intervals spread out, however many we had. Just make sure the last one winds up out near the edge here. And then you want to answer these questions. And you can submit a picture. You can submit a picture of this page. I also want you to do this one. This is pretty easy. Okay? Do the same kind of thing here. Graph the distance, just the distance between those on here. That's an easy one. And that is considered part of this. Okay? So submit that and that. I don't need a picture of this page. Okay? So that's modeling expansion in the universe. I guess we'll keep this balloon inflated. So that was modeling expansion in the universe using a balloon. Okay, it can also be done with a rubber band, but that analogy is a little weaker. And the best analogy is one I'm not showing you, but you have to sort of imagine the raisin bread dough. Okay, bye-bye.